So what we're going to be doing now is we're going to go back to 16.1 that we already did, but we're going to do the second part of it. Let's review what the first part of it was. The first part of it was, let me go ahead and use a highlighter, it'll be better. The first part of it was the distance around a circle, which is called the circumference of a circle. And we had two formulas for the circumference of a circle. They're pretty much the same formula, but the book wants you to think that they're different, at least at first. Circumference is 2 pi r or pi d. And those are the formulas for circumference. Let me go ahead and write that down here. Circumference. Okay, so for example, in this problem, if I want the circumference of this circle, it's 2 times pi times 9, or 18 pi inches. That's the circumference of this circle. And once again, that's the distance around the circle. Okay, so that's the old stuff. So what are we doing today? Today we're doing area of a circle. If you remember from earlier in the year, the area is the space within a plane region. And the way that that space is measured is with squares. It's how many squares, I'm doing a rough estimate here. It's how many squares fit within a plane region. Now, obviously, you can't just sit here and count squares, especially since mine are really ugly and not done to scale, but you can't just sit there and count squares. There has to be a better way. There has to be a formula, and there is. Just like there was formulas for circumference, there's a formula for area, and that's what we're going to be doing today, okay? Don't forget, for area, what we're doing is we're trying to find the amount of space within. See if I can draw here. My marker is being difficult. So area is the amount of squares within a shape. It's not the distance around like circumference was, it's the space inside measured in squares. So the way we're going to be doing this is by taking a circle and we're going to divide it up into sectors, okay? So here is a circle. If you remember what a sector is like a traditional pizza slice. A sector is, if you remember from the beginning of the section, when we did our vocabulary chart, it's the region between two radii and an arc of a circle. That's called a sector. So I'm going to take this circle and I'm going to divide it into sectors. First, I'm going to divide it into halves, okay? These are halves. See, I divided it in half, and I'm going to rearrange them, one up, one down. Just like I did before when I derived area formulas, I always derive the area formulas from a previous formula. So I'm going to do the same thing. I'm going to try to relate the circle in terms of a previous formula. So here I have halves, and that looks like nothing. Okay. Here I have the same circle divided into thirds. Thirds. And I'm going to rearrange them, one up, one down, one up, one down. So it doesn't look like anything, right? Okay, I'm going to keep on doing this. And for the sake of time, I had already done it, okay? Here I have it divided into halves, into thirds, into fourths. Not sure if you notice anything. Does it look like any shape we've done previously, like a kite or a triangle? Okay, right now, no. So here I have it divided some more. Here I have it divided into fifths, into sixths, into eighths. I jumped to eighths. Notice that each of these is 1/8. And it's starting to look like something. Again, if you compare when it was halves, thirds, fourths, fifths, sixths, eighths, I think it's starting to resemble something. What do you think you see? A previous shape that we've already done. Hopefully you're seeing something. I broke it down even further into, this is 1, 2, 3, 4. This is tenths. And then the black one is twelfths. What does this look like? Well, I think it looks like a, I don't know, maybe like a parallelogram. Okay, at least it resembles a parallelogram more so than the original one when it was broken into halves. Okay, so that's what and twelfths is the smallest one I have, so we're gonna go by twelfths. Okay, so I'm gonna show it to you on my screen. So you see how we're deriving this formula from the formula, from the area formula for a parallelogram, okay? So it just so happens that I have the 12ths here, and I'm going to show you what I'm doing here. Here are the 12ths. I divided the sectors into 12 congruent pieces. I divided the circle, I'm sorry, into 12 congruent pieces. So the first thing I'm going to do is I'm going to use the area formula for a parallelogram. If you remember, that area formula was base times height. So I need the base. The base would be this. This would be the base of the parallelogram, okay? And the height would be this, the perpendicular distance between the bases, okay? That would be the height, the perpendicular distance between the bases. So let's start with the height. In terms of the height, if I take this shape here, okay, and I rearrange, and I just put it off to the side, the height would be the distance from the very, very edge down to that peak. Okay, that would be the height. Now, I don't know if you caught something I did there by mistake. That's okay. A little bit of a preview, a little bit of a sneak peek. From the very, very edge, from a point on the very, very edge down to that peak is the radius of the circle. So the height of the parallelogram is the radius of the circle. Okay, so that's one down. So the height of the parallelogram is the radius of the circle. What about the base of the parallelogram? The base of the parallelogram would be all of these lengths here, all of these lengths. So let's focus on those lengths. Let me just pull them out. Those bottom lengths put together. Combined, that would be the base of the parallelogram. But if we put that back on the original circle, if we put all of those back on the original circle, notice that those base edges are these lengths. From here is this length, from here to here, or basically around the edge of the circle, which is circumference. Okay, now, it's not all the way around, it's halfway around. So these bottom edges, which represent the base of the parallelogram, is half of the circumference of the circle. Let me put them back in here. Those bottom edges, which represent the base of the parallelogram, is half of the circumference of the circle. Okay, so again, this would be half of the circumference of the circle. The formula for circumference of a circle is 2 pi r. So if you notice, the 2's cancel, so I'm left with pi r. So the base of the parallelogram is pi r. So the area formula would be pi r times r, which is pi r squared. Ta-da! That's the area formula for a circle, pi r squared. Now, we're going to go back to our circle here that we had originally, and we're going to go ahead and calculate the area of this circle. Now, if we calculate the area of this circle, the area formula that we just said was pi times radius squared. Okay, now the radius of this circle was 9, so the area is pi times radius squared, which is pi times 9 squared, or 81 pi. Now don't forget, area is square units, so that's 81 pi square inches. You can also write that as inches to the second power. Don't forget that this is an exact answer. If I ask you to plug in pi, if I ask you for an approximate answer, use your pi key. So note the difference. Circumference is the distance around the circle. It is 2 pi r or pi d. And if I do it for this problem, it was 18 pi. The area formula is pi r squared. So many kids think, oh, they're the same formula. Look, you got a 2, you got a pi, you got an r. You got a 2, you got a pi, you got an r. It's not the same thing. This is the radius times 2. This means radius times radius. So it's not the same thing. Completely different answers. Okay? Okay, so you're going to have a lot of problems in the book where they ask you to get the area of a circle, and you would just plug into this formula. Okay, pi r squared. So what I'd like to do now is I'd like to do some more difficult problems, because you've done area since you were in Well, maybe I'll do one more. I'll do one more before I get to the hard ones. So let's say I give you this circle, and I tell you that the radius is 5 feet. Let's go ahead and find the exact and the approximate area. So find the exact and approximate area. Okay, so the area formula is pi r squared. So it would be pi times 5 squared, or 25 pi square feet. That would be the exact answer. Exact means you keep the pi in the answer. And if I ask you for the approximate answer, do 25 times, please use the pi key on your calculator. It's just more accurate. The more decimal places you use, the more accurate your answer. Okay, so if you just do 25 times pi, it's going to be 70, and round to the nearest tenths, it's about 78.5 square feet. So this is the exact answer. And the one that I just did is the approximate answer. Okay, so now let's do more challenging questions because you are in an honors or honors gifted course in a magnet school. So something like this. Remember these area of a shaded region problems? And don't say no, you don't remember, because you do remember. Those were good times back when we were at school. And I happen to have it here to refresh your memory. And I even still have it on my website. The way we would do this is we'd get the area of the whole thing and subtract the area of the inside part, the part that we don't want, and what was left over was the shaded region. Okay, so we're going to be doing that here. We're going to get the area of a shaded region between two shapes, but this time, now that we know the area formula for a circle, we're going to be able to use that formula. Okay, so are you ready for these? Oops, where did my shape go? Okay, so we're going to go ahead and get the area of this shaded region, and my pen is being difficult right now. Okay, so I need the area of the shaded region, which my shading is not great, but you get the idea. It's the region between this square. I'm telling you that it's a square. This circle is inscribed in the square, means that the sides of the square are tangent to the circle. So the way we would do this is the way we did the shaded region problems before, okay? So to get the area of the shaded region, as we did before, we would get the area of the outside shape, we get the area of the inside shape, and we subtract them. That's all you do for these, okay? And you know what? I'm going to take it a step further. I want you to give me the exact answer and the approximate answer. Okay, so to do this, let's write down what the outside and the inside shapes are. The outside shape is a square. I said it was a square. And the inside shape is a circle. So we're going to do the area of the square minus the area of the circle. Please write down the formulas for both. The square is base times height, and the circle is pi r squared. Don't forget that for a square, you can also use the rhombus formula, which is half diagonal 1 times diagonal 2 if you ever have the diagonals. Okay, so the base of this square, if this radius is 9, that would translate over here. That means that this piece is 9. The radius over here would be 9 as well. So what is 9 plus 9? 9 plus 9 is 18. And because it's a square, all the sides are the same. So it'd be 18 times 18. Now the radius of the circle is 9, so it's pi times 9 squared. 18 times 18 is 324. So 324 minus 81 pi square inches. That is the exact answer. Remember, you cannot subtract them because one has a pi, one doesn't. If I ask you for the exact answer, you're done there. Now, if I were to ask you for an approximate answer, okay, first you would have to multiply 81 times pi and then subtract that from 324. if you just type it into your scientific calculator will know to do the multiplication before the subtraction. So if you do that, it'll be 69.5 square inches. That's the approximate answer. Now, what about if the square is inside the circle? Ooh, so it would be backwards. It just so happens that I have that ready for you here. So again, if I ask you for the area of a shaded region like this, okay, then you do the same thing. The first thing you do to get the area of a shaded region, don't worry about some formula for it, just think about what's happening each time. To get the area of the shaded region, you do the area of the outside shape minus the area of the inside shape. And then all you got to do is subtract them. So for the outside shape, this time it's a circle. This time the square is inscribed in the circle. And I'm telling you it's a square. I constructed it that way. Okay, so the circle goes first and the square goes second. Okay, so what is the radius of the circle? That hasn't changed, it's 9. Now, for the square, notice I put base times height. Now, I don't know the base. I don't know the height. Now, you could do a bunch of things that we've done before. You can remember that the diagonals are going to be congruent because it is a rectangle, therefore, and that they bisect each other. Therefore, if this is 9, and they're perpendicular because it's a rhombus, and then you'd have here a 45, 45, 90, so this would be 9 square root of 2. You can use that as the base and that as the height as well. You can do that, no problem. Okay, that's great. But this is why I tell you it's good to know other methods. Instead of using base times height, for a square, you can also use the kite formula. Half diagonal 1 times diagonal 2. That'll be a lot easier because this is 9. This is also a radius, so this is 9. So the entire diagonal, this entire diagonal would be 18. And then the other diagonal would be 18 as well because a square is a rectangle and the diagonals are congruent. A lot easier just if you know other methods. So then it's going to be 9 squared, which is 81 pi. That's the area of everything. But again, I don't want the white part. I don't want the square. So subtract half of 18 times 18. So if you do that, that's going to be 162. So 81 pi minus 162 square inches. Again, that would be the exact answer. Now, if I go ahead and I approximate that, please use the pi key on your calculator. It'll be about 92.5 square inches. And again, it's not going to always be a square in a circle. It might be a circle within a circle. It might be other shapes. But just remember, even if it was a circle within a circle, like concentric circles like this, you might have that. And if you do have a problem like that, the region between two concentric circles, that was also one of our vocabulary words. That's called an annulus. Just think about how you would do it. You would get the area of the big circle and subtract the area of the small circle. Of course, they would have different radii, okay? This radius would be for the big circle, and this radius would be for the small circle. Some people call it capital R for the big circle's radius, lowercase r. It doesn't matter. It's just the area of the two circles subtracted. Okay, and with that, you should be able to do the problems with the area of a circle. Good luck.